Welcome, everyone. My name is Sierra Flanigan, and I'm joined here by my dad, Ted Flanigan. We're a father-daughter duo committed to a livable planet, and this is part of my dad's Flanigan's Ecologic podcast, which has now surpassed over 100 different episodes. And as part of that, we are hosting these clean energy crash courses. Actually, we just determined that today is number 10 in total that we've recorded together. I think 12 in total, with a couple of special guests on the program. And so our goal here is to demystify complex energy and climate topics. Whether this is brand new to you or familiar terrain, our hope is to give you a 30-minute download. And with this massive transition, as we're all aware, moving to clean energy, there's new demands being placed on our existing grid. So how do we ensure that we have the capacity to fully electrify our energy system? So welcome, Dad. It's great to be with you here, as always.
Thank you.
And this was your request. Why did you want to focus on the grid today?
Well, things are heating up, aren't they? This
That's
summer, boy, oh boy, I can't. First off, it's just great to be here with you. But yeah, the summer heat is here, and here in LA, we normally have our hottest temps in August and October and September and October. But boy, oh boy, Phoenix has just had over 12 days of temps over 110, and there's the ocean waters around Florida are over in the high 90s. I mean, it's just very alarming. So I thought it would be valuable to talk about the power grid and to talk about how the grid handles this kind of stress. And this is I'll be focusing mostly on California because that's where I am and have quite a bit of data and information. But I think the same thing is true around the country. So I thought maybe we'd talk a little bit about the power grid, try to bring the power grid down to basics, and then also segue a little later in the podcast and talk a little bit about how we can each sort of take responsibility for our role in that power grid.
Great. So first, let's just bring it down to the bare bones, the basics. What is an energy grid in the first place? Can you kind of paint the picture for us, for our listeners?
Sure. Yeah, I mean, the simplest thing is that everybody's seen a power plant, and the power plant produces power, whether it's using coal or natural gas or whether it's nuclear or whatnot. And next to the power plant or attached to the power plant are transmission lines. So they're taking high voltage from that power plant, distributing it often over long distances, high voltage transmission. And then when the transmission gets to a city or a region, that high voltage transmission is stepped down into distribution lines, and we've all seen distribution lines all throughout our communities. I like to think of a power system, and I know this is oversimplifying it, but sort of like a plumbing system. And so imagine in California, we used to say this about 10 years ago, we used to say there's about 1,000 power plants in California, right? Those are all like pumps on a plumbing system. So they're all pushing water into the system and pushing water through the system and into our individual homes. So it's a big, huge, complex system that in California is managed by something called the California Independent System Operator. And there's different independent system operators around the country, and they manage all of the utilities power plants, sort of optimizing throughout the day. And here we are at the beginning of the summer, and so the ISO, the Independent System Operator, is getting ready, and everybody's getting ready for this extreme heat because, as you know, when it becomes really hot, people all turn on their air conditioners, and it's that air conditioning load that just drives up this mountain of demand during the day and into the evening.
So back in 2005, you actually helped develop a children's book about California's electricity traffic jam. Could you bring us up to speed on that?
Yeah, it was fun. It's fun recalling that experience. But I was with Patty Wagner, who was an official at San Diego Gas and Electric, and I guess it was in the spring of 2005, and we were facing yet another summer of all sorts of extreme heat and therefore duress on the power system. And we came up with the idea of trying to educate kids about the power system. And most kids they don't really understand where it's coming from. So we decided to to create a little booklet that I wrote. It's called the Electricity Traffic Jam. And everybody knows what a traffic jam is. Every single kid has been in a traffic jam. So we tried to use that as a metaphor for the power system. Anyway, we produced this little booklet with San Diego Gas and Electric. I was at the Energy Coalition at the time. We distributed it that spring to 130,000, I guess it was third grade students throughout the San Diego school district, to get them to focus on this whole issue of the electricity traffic jam. And that on the hottest day of the summer, or the hottest plural days of the summer, we have to take action. So we had, it was fun. We had, there was a coloring book, and there was sort of follow, by numbers, and there was crossword puzzles with word like peak demand in it, and other things that we were trying to educate these kids about. Because with education, then we start to turn things off at those peak periods for the sake of all of us.
And I remember vividly Bulb Man, the superhero, who, as I recall, went onboarded on trains and handed out CFL light bulbs at the time.
Yeah, this was a fun time. We decided to put together a mascot, and we named him Bulb Man, and we hired an actor who would be Bulb Man and wear this silly suit. And Bulb Man didn't speak, so it was all gestures. And Bulb Man adorned the cover of this little booklet I'm talking about. But yeah, it was all the same thing. We were trying to raise awareness about peak demand because, in California and probably all around the country in different parts of the world, on the average day, the power system can handle it, right? It's really, it's designed for the average. It's designed for well above the average day, but on the average day, the power system can handle it. But you get into these peak situations where, Las Vegas is supposed to hit 120 degrees in the next day or two. Never been there before. We get these peak situations, and that's what really stresses out the power grid. And so I think it's important for people to understand that.
Absolutely. And obviously technology has evolved immensely since the days of the compact fluorescent light bulb, and LEDs are all the rage, but we won't go down that path. Rather, what else has changed in the past 20 years since the days of Bulb Man?
Yeah, back those days, in those days, we used to think that 350 parts per million, and that's CO2 equivalent in the atmosphere, that 350, in fact, Bill McKibben's organization, 350.org, was founded based on this threshold that we thought, and the climate scientist said, was the maximum, after which we would have climate calamities like we had never experienced before. Well, here we are today. Actually, it was in May, a reading on the top of Mount Mauna Loa out in Hawaii, 424 parts per million, right? So we're way past the threshold that we thought would never be exceeded. We talked about this last time. Since industrial times, in more than a million years, we've never had this. We've never had this level. Now, that's the bad news. The good news is on the power system side, is that we've really revolutionized our power system. I mentioned earlier that we, in the old days, we had 1,000 power plants in California. We had big ones, maybe a dozen really big ones, but then, of size, we had 1,000. Well, now there's probably millions of power plants because there's all of these distributed generators all over the place that are feeding into the grid and that are linked with the grid. So we've talked about the term virtual power plant. But in a way, we have a virtual power plant in that we, instead of having a big, huge centralized power plant, now we have lots of little power plants that are cutting down that peak demand and that are making contributions to the grid. And I think that's really, really exciting. I think that I'm going to talk a little bit about energy management, but these localized resources, as opposed to the large central power plant with the big high voltage transmission lines coming over hill and dale over hundreds of miles, now we have more and more local resources. And these are also being backed up with about 5,000 megawatts of energy storage now on the California grid. That's a big number for California. This is a huge rise in energy storage. On the maximum peak day in California that we've had to date, 52,000 gigawatts. I'll talk a little bit about a gigawatt. But now we have 5,000 gigawatts of storage. So We have a tenth of that capacity now in storage. By the way, a gigawatt is 1,000 megawatts. And
Okay.
that's about, if you think about, that's like a large power plant, or like that's a nuclear reactor. The reactors at San Onofre, which are now closed, were each 11,000 megawatts. So I always think of a gigawatt as being about a nuclear reactor, right? And so in California, on the hottest day of summer, we required in 2022, we required 52,000 megawatts of capacity. Right now, I just looked this morning at the California ISO numbers, and we're forecasting, actually, we were running about an hour ago, we were using about 29 gigawatts, 29,000 megawatts of capacity. And by the way, out of that, it's just around 30 gigawatts of capacity. Of that, an hour ago, 15,000 or 15 gigawatts, half of that was being supplied by solar. Now, today
Wow.
we're expected to get up to 40,000 gigawatts. So we're way below the peak, the intense peaks that threaten our power system. But again, we're getting ready for that. We're getting ready for that.
So despite the extreme heats, the California power grid in its current state is able to handle the peak demands on it from the grid.
Yeah, that's right. And today, I think, the ISO tells you how much capacity is available on the grid. And right now we have 49 gigawatts of available capacity. I said that we're expected to hit 40 gigawatts of peak today. So we have a nice, healthy reserve margin right now. But, as we get up into the extreme heat situations, then all sorts of things can happen too. You might end up with a wildfire that's going on that knocks out a transmission line.
Right.
And if that happens, then then all hell breaks loose, right?
Well, so let's go there. I mean, it's really hot. There's some wildfire, but what happens in these moments of peak demand when the capacity is short?
Yeah, and I'm going to talk about this load profile, but you can imagine that during the day, we have that sort of an evening load, and then during the day, people wake up and they go to work, and industries fire up, and power more and more power consumption, and we have these load profiles that are like a mountain of use. So on the hottest day, yes, we have this mountain of use just getting higher and higher and higher, and the utilities fire up everything they got. They've got power plants that they'd rather not operate because they're not as cost effective to operate, or they have some environmental controls on them. The utilities seek imports, but of course, everybody's seeking imports if the whole region is hot. So that's kind of a problematic thing. Something I learned in the past couple years is that transmission lines have to be derated when it gets really, really hot. So you're kind of at odds. Just at the time you need the most capacity coming in is when often these lines have to be derated. So that's trouble.
What does derated mean?
That means that they have to carry less power, right? Yeah. So if they were able to carry a megawatt of power, maybe they have to be derated to 900 kilowatts of power. Yeah, so
And that's just for safety purposes or for?
I think that is. Otherwise, they just burn up or melt down or
Yeah.
whatever they do. So it's yeah. But again, just right at that peak period is when everybody's got their air conditioner on. Everybody's got this demand. All the utilities are vying to buy power on the market. I mean, we won't talk about all the market rates in the past, but I mean, there's been huge prices paid for peak power. And of course, that's when the utilities, call on all their customers, any customer that's involved in a load management program that can
Right.
curtail load, or what they call a demand response program that can curtail load. I think we might have mentioned this in another podcast, but the utilities in California are paying up to $2 a kilowatt hour to groups that can curtail their load during these super peak periods. So there's tremendous value in getting people to cut their loads. But worst case, you end up with rolling blackouts, and the utilities have to roll these blackouts through the communities, and that's a really bad situation for everybody.
Yeah. So to avoid this situation, there's smart energy management. And of course, the utility is advocating for this because they don't want to build another expensive power plant, right? So I think from the demand side and from the consumer side, what can folks do at home? I mean, if there's somebody who's not part of a program where you can shut down your energy to kind of curb peak hours. How can folks get involved?
Yeah, I think there's a lot of things to do, and I've been talking with my colleagues this week about, just taking more action, because I think we have to take more action during heat waves to conserve, and we also have to take more action um, in addressing the climate crisis, and just take bigger actions in general. But I developed this notion when I was at the Energy Coalition and we were working with schools and children around third grade, fourth grade. I developed this notion of smart energy management. And so, what do you do if you're a good, responsible Earth citizen? And it seems to me that there's four basic aspects of smart energy management that we all can do. And the first one I've mentioned already is conservation. And
Mhm.
conservation is conserving resources, which just means turning stuff off. And it's just unbelievable how much stuff is left on in our society that's not benefiting anybody. And, obviously we've all been taught to turn off our light bulbs. Absolutely. But there's all sorts of phantom loads in our houses and control boxes for televisions and things. There's quite a few things that can be turned off and can be effectively turned off. And when you turn stuff off, obviously that mountain of energy use or electricity use, obviously it comes down. Um, and I think almost all of us could go through our homes and figure out ways of cutting 5%
Mhm.
of our energy use during a peak day event by turning things off, making sure that we're not um, using major appliances during those periods too. But the second aspect is energy efficiency, and we've talked about this lots before. But energy efficiency just brings that mountain down, right? So it's everything. It's better lighting, and of course, anybody that hasn't changed out their compact fluorescent lights now to LEDs, you're sort of behind the curve here. It's time to do so. Save money. Fantastic technology, lasts longer as well. But lighting is really important. HVAC units. If people have really old central HVAC units, probably time to change out your condensers. It's going to be a cost, but it'll have a payback. Lots of ways that we can that we can get to more efficient appliances and more efficient uses of our electricity, whether it's lighting or air conditioning or it's our refrigerator or whatnot. Even pool pumps, the newer pool pumps with variable frequency drives are all saving a lot of money. The third aspect of how to be part of the solution to this, the power grid under duress, is just managing your load and making sure that you're not doing things on peak if you don't need to. And a good example of that is, when do you do your laundry? Well, your laundry should be done in the evening, or in the late evening or in the early morning, off peak. Same with charging electric vehicles, should all be done off peak. So we try to manage loads. In fact, in the commercial sector, there's even ways we can pre-cool buildings, right? Getting buildings pre-cooled before we get to the peak period, and then turning down the air conditioning during the peak period and letting that building coast a little. And then the fourth aspect of what I call smart energy management, we've been through conservation, just cutting use, efficiency, making sure everything you got is super efficient, managing your load in terms of time of use when you do stuff. The fourth aspect is, filling in whatever's left of that mountain of use. Hopefully that mountain's a lot smaller now and flatter, but filling in whatever's less with renewable energy and local distributed renewable energy. And so, I'm in this business of promoting solar energy and battery systems and all. Sometimes it can be a great investment, right? There's also leasing programs for people that don't have the cash. So these are really great steps that can be taken right away, and to alleviate the grid.
Yeah, I think we're all feeling the heat. Literally, we've had some of the hottest days on human record just in the past weeks. So it can feel a little distressing for sure. Linking back to our last podcast on kind of climate action 101, I mean, you've just laid out some great options. What can folks do right now to see the results they're looking for and fast?
Yeah, I think there's just such a wide range of things to do, and I guess I would just encourage all of us, myself included. What more can I do today? When I look at the heat wave that's going around the country, around the world, it's unprecedented. I mean, this is the time for action. What can I do today to take a specific step? EcoMotion has this trademark term, the power of the increment. It feels really good to take a step. And as I think about it, I'm thinking, what can I do? Well, I do have some old compact fluorescents up in a bedroom that I could swap out. Maybe it's time to do that. I think I have a few incandescent light bulbs actually in my little laundry room that I haven't ever taken care of. Little stuff, right? That we can do. So there's the really little steps. I was proud of my colleague Michael Ware, who is he's just invested. He was really trying to decarbonize his home in Santa Monica, and I think he's putting in an electric heat pump clothes dryer. I think that's what's going in there. So that's an exciting step, and he's had trouble finding vendors that have the right equipment and have the knowledge to put them in, but he's committed to doing that. You've heard me talking about EVs. I'm just blown away. I mean, anybody that hasn't test driven an EV and then is in the cusp of getting another vehicle for whatever reason, I would so strongly encourage checking that out. So there's sort of the no cost little things that we can do. I remember years ago when I worked at LADWP and we were getting ready for the summer, I was the director of efficiency solutions, and I went on Coast Radio and just talked about if you don't have any cash and you're in an apartment, what do you do in the heat of the summer? And we were, closing the drapes, things like that, making sure that the refrigerator is not open very often, cleaning filters. Sometimes if you have a ventilation system and the filters are clogged, it's fighting itself. So there's all these little steps. And then the really big steps are sort of on the policy front. And we need to be very vocal about what's going on. We need to make sure that, like, as you said at the top of this discussion, as we decarbonize, our buildings and our mobility, we've got to make sure that our power system can really handle it, and that we've really geared up our renewables and we've really geared up our storage.
Right. So we noted this in our last conversation, just the irony that in order to address the urgency of the matter, sometimes we just have to slow down and start with ourselves, start with our homes. I love that. What can I do more today? Oh, I guess I could walk to yoga instead of drive, or, close the drapes. From small to large, and then advocating for policy change, making your local representatives, national representatives know how you're feeling. And so we can tip the scales on some big policy changes as well. So, and I also loved your point about, in our last conversation, about how so many of our life choices, 80%, I think you said, start around the dinner table. So just kind of bringing it down to a personal, family, home level, and then kind of moving out from there.
I think that's right. There's so many little steps that we all can take, and it's not that we've gotten sloppy or complacent. I think we just need to take it now to the next level, right? I think, and one thing that I've been grappling with is how bad does it have to get? I mean, watching the news now and seeing the effects of climate change. I mean, the flooding in Vermont. I mean, it's just unbelievable amount of flooding. I think Bernie Sanders said, climate change is here. I mean, it is here. The intensities that we've seen. So yeah, I think it's time to take it to the next level. I've been grappling with this question of how bad does it have to get? Do we have to have more and more and more calamities and more costly calamities? I know the insurance industry is going to be very instrumental.
Mm-hmm.
Apparently pulling out of Florida, for example. So there will be. Do we have to wait until we get to these crises? I hope that's not the case. Anyway, we keep trying to take very positive steps, incremental steps, to avert this. But again, I think it's time for all of us to ask, what more can we do right now?
Right. And there's no shortage of news about how these issues are so very real and impacting lives and livelihoods around the country, around the planet. And yet that doom and gloom mentality just doesn't help at all, does it? So is there room for optimism, Dad? does it really have to be so bad before we can really take a turn here?
Well, I am afraid that it has to get really bad, and that's when the forest fire burns, that's when you have room for new growth. I hate to hear myself say that because it's so illogical, and there will be so much destruction, and we're doing things that clearly we'll regret later. Our children will be saying, "What were you thinking? You could have made this and that decision and averted all these crises." But the thing that where I get my optimism is and it's an overwhelming sense of optimism is looking at the pace of innovation
Mhm.
and looking at how companies now, a whole new cadre of companies are coming forth to restore, right? I guess some are being involved in the adaptation to climate change, but what excites me is the restoration. Um, I've been really, as you know, I've been really into studying oysters and how oysters can restore marine ecology, marine ecosystems. It's fantastic. But there's all sorts of work with businesses that are pulling pollution out of the ocean and turning that into products. And I think there will be lots of work with carbon capture and storage, and different. There's different types of cement that absorb CO2. I mean, and we're moving towards the level. The solutions are all out there, and the innovation, the pace of innovation is so great. That's what gives me my optimism. We just take that whole global innovation that we've put towards things like developing the internet and cell phones and our great information society that we have today, but take all those smarts and take the smarts from the aerospace industry and every engineering disciplines, and take the smarts from the social scientists as well, that can figure out how to create really sustainable living here on the planet, which is really what we need to get to.
Yeah, and I think that story and that invitation of this bright, beautiful future that we're working toward is really motivating. Um, and you also made mention of nature-based solutions and the ability of oysters and shellfish to sequester carbon and lots of other plants. And so, a lot of this is just turning back to the earth and saying, hey, how do we go about this? She's been rapid prototyping for 4.3 billion years. So I think combining our human innovation with the earth's inherent innovation and intelligence to regenerate could make for a really, really bright future. So thank you so much, Dad, for this conversation. I want to make sure you have room to make any closing statements if you have them.
Oh, well, thank you. I think it really boils down to the quality of life. So we want to have a high quality of life where we're well fed and comfortable, and we have family and friends, and we have interests and passions. Um, and we need to do that in a way that's sustainable, right? And so we spent the past half hour talking about the power grid and recognizing that each of us has a really important role in the power grid and in the demand that we put on the power grid and how we shape that power grid. And as we get into the heat of the summer, I guess I'm just asking all of us, myself included, to take that additional step.
Right. And the power grid maybe it sounds arcane and kind of technical, and yet that's sort of this connectivity between all of us and our activities. So I think being reminded that we are all the energy grid and we're contributing and revolutionizing the grid, like you said, with more distributive energy systems. Very, very exciting evolutions going on in this space, and we will make sure that we keep track and keep you all attuned to developments in this industry. Dad, thank you so much for another great conversation about the power grid. I've certainly learned a few things and am inspired to make a few extra changes today in my life. So everybody have a wonderful rest of your day. Thanks for tuning in, and make sure to catch us next time on Flanigan's Ecologic.